Well, welcome to Surface Area and Volume of Spheres with Mr. Hunt. Let's start off with the formulas for surface area and volume of a sphere, and then we're going to try several examples. For surface area of a sphere, I have a little demonstration here on the page, but really I have two, possibly more. I might add some more really good video links on Canvas. So check those out. It just video links. It nicely illustrates surface area of a sphere. And basically it boils down to this. If you take any ball, I here have a baseball, it might be the best one to kind of illustrate here, but really any ball, you take the outer covering, it's gonna look like this. This area in between, it's just because the figures, really, I mean, it's gonna be four perfect circles here. I can't get rid of that middle area, but it's because these circles themselves are kind of skewed. They're not perfect, so it's made up here by this. In any case, here's what happens. You will have four perfect circles that are formed with the radius of r. And this sphere, okay, imagine it was going through and everything. That this sphere has a radius of r. So there are four circles, and we know each circle is pi r squared. Again, check out the videos online. There's a great one with an orange. I mean, you could do this at home. Take an orange, put on paper the radius of that orange and make a circle, make four of them, peel the orange, and you'll be able to place on your four circles the entire peel of the orange. Okay, assuming your orange is perfectly spherical. So check that out, that's a good one. Let's go to the volume one. This one we can derive very nicely. So what's the volume of a sphere? Here's what I want you to do. Make this drawing, and yes, I do want you to draw this. I gave you a lot of space for it. Make this drawing of a sphere. Imagine I have these arcs going across. There's a reason I'm drawing these in. So just draw these arcs. Cool little fact I'll mention here when we come with the hemispheres. If you have, I'll do one more. If you have a, a circle in a sphere that's going through the center, it's called a great circle. It's a nice little fun fact. So, here's what I'm going to do. If I pull out one of these, it's going to be, they're near pyramids. So, let's see if I can kind of draw this in here. Imagine that I've taken out this pyramid. I'm trying to three-dimensional going in. That's supposed to be, that piece is going into the sphere to the center. All right? Imagine I pulled that out. What would it look like? Okay? It is going to be, almost a pyramid. Now, notice, what is the base of my pyramid, or near pyramid? It's actually curved slightly, right? Because it is, it's really curved on the sphere. But if we had an infinite number of these pyramids and made them smaller and smaller, well, it would basically be flat instead. All right? But they would be pyramids going into the inside. The way I'm going to show this is similar to the surface area of a pyramid. Remember that one where we had our net, I don't remember what it was, but then we had all these triangles that we fit up. That's not a good one, but we had all these triangles, and we added up all, we had the base, and then we added up all the triangles together, however many there were, and that gave us the formula. All right, so let's do the volume of the sphere here. What it's going to be is I'm going to add up all the pyramids, right? Add up all of them. Imagine I went an infinite number. So it's going to be the volume of pyramid, I'll just write P1, volume of pyramid 1 plus volume of pyramid 2 plus volume of pyramid 3. Let's keep writing them forever. No. Let's do dot, dot, dot. So we're going to add up all the pyramids of the sphere that we break it up into. Well, what's the volume of each one? We know the formula for pyramid, 1/3 capital B times H. Now I'm going to put 1 here as well because this is the first pyramid base and height. Here's the second pyramid, capital B2, height 2. Nope. What? Plus 1/3 capital B 3H3 plus dot dot dot, right? We add up all the pyramids. Here's what's cool. Now let's think about this. What is the height, H1, H2, and H3? For all of them, the height of the pyramid, since we're going to the center, is going to be R. For all of them. They're all going to be equal. So I'm going to change all of the heights to just R, the radius of the sphere. Because that's cool. What else do we know here that we can simplify, plus all the rest? Well, isn't there 1/3 that's common to all of them? Well, if it's common to all, we can factor it out. So I have 1/3. Oh, and get rid of that so I have more room. Well, at the same time, well, now we have R common to all of them as well. So let's factor out a 1/3 and an R. Now we got the base 1 plus base, remember this is base area. Okay, I'll go back there, I don't want that. This is base area. And then we'll add up all the rest of them, plus dot dot dot. You ready for the best part here? This is fun. I love this. So let's see here. Let's go right. Well, what is base area 1 plus base area 2 plus base area 3 plus all of them? Right? That might be 1. Here's 2. There's 3. There's 4. Right? If we added up all of the bases, what is that? Hopefully you're taking a guess at what it is. We have 1/3 R. This, adding up all the bases, is the surface area. And what is the surface area of a sphere? Well, we just talked about it. It is 4 pi r squared. So when we work this out, we do 4 times 1/3. I do 4 times 1, it's 4/3. Then I have a pi, and then r times r squared is r cubed. So hopefully it's similar to the pyramid one, adding up all the triangles before. This one is adding up all of the pyramids. Okay, example number 1. A baseball has a circumference of 9 inches. How much leather is needed to cover the ball? So first, what is the question asking for? How much leather is needed to cover the ball? The covering would be the surface area. So it's 4 pi r squared, write down the formula. Now, great thing about formulas for spheres, surface area, and volume, you only need the radius. Well, we don't have the radius, but we have the circumference. And remember, we did examples like this in our circles unit, talking about circumference. Plug in 9 into the circumference formula, and then we can divide by 2 pi on both sides to get r. Put it in parentheses, or you can divide it one at a time. Oops, sorry about that. And you're going to get about 1.43 for r. Okay, and you put that up here. Something else I want to point out here. When you put this in, okay, don't, in your calculator, right, you did 9 divided by 2 pi. Just leave the value in your calculator, okay? Don't actually then retype 1.43, because it's not actually 1.43, okay? It's decimal version of that, okay? It's actually, if I get it here, hold on, 2 pi, it's actually 1.43239, all that. So anyways, square it times 4 pi, it's going to be about 25.78 inches squared. So this is all about, don't round too early. And really, if I'm going to start encouraging 3 decimal places, 7.783. If you had just put in 1.43, you would have gotten 25.697. Now, still very close, right? But I mean, it is a different number, so don't round too early, that's the point. Next example, find the surface area and volume of a hemisphere with radius 3.6. Probably my favorite example on here. So you got to think, well, hemisphere, let's actually do volume first. Okay, I give you the radius. Straight up give you the radius. So for volume, just plug it in. 3.6 cubed. So in your calculator, 3.6 caret 3 is the cubed. Then it doesn't matter what you do next. Do you want to do times 4/3? Or do you want to do times pi? Or do it all at once? It's going to work out either way. So I get about, let's see, about 195.43. Now, that is the volume of the whole sphere. This is a hemisphere, right? It's half the sphere. I imagine it's cut exactly in half. Half the sphere. So what do we need to do now? We need to divide by 2. All right, now you're about 97.7 inches. 716, if I could be a little bit more precise. 6 cubic inches. Okay. Now, what else could we have done if you didn't want to? That's probably the easiest way, right? Find the volume, divide by 2. What else you could have done though is you could have gone back to the formula here, and well, the volume is going to be half of this, right? I divided it by 2 at the end. If I wanted to though, I could have changed the formulas. Half of 4/3 would have been 2/3. And then I could have just used the formula as is. Okay. I would recommend though, just do the volume, divide by 2. All right. But either way. Now surface area formula is the best one here. 4 pi r squared. So you just need the radius again. Okay. But hold on. For surface area, do you think we could just do this and then cut it in half? Well, not quite. Because when we cut it in half, we actually expose another surface here. It's a circle, and it has a radius of r. So guess what? You cut the formula in half to start, because it's a hemisphere. So this around the edge is only going to be 2 pi r squared. But you then have to add in, there's an extra circle that's formed, so you have to add in 1 more pi r squared. And so, here we go, it's going to be 3 pi r squared. So, this is not on the formula sheet either. Surface area of a sphere, hemisphere, 3 pi r squared. So we put that in, 3 pi, radius 3.6 squared. You get about 122.145 inches squared. Okay. Feel free to pause and review this. Example 3 and 4, and then we'll be done. Earth's equator. Oh, this is a good one. Approximately 24,902. Determine the surface area of the Earth. Okay, surface area, 4 pi r squared. I can write this. Oh, gosh. 4 pi r squared. Okay, so we just need the radius for that. Now, to get the radius, well, we got to think about what we're given. We're given the equator. If I have a, by the way, the Earth is a near sphere. It's not perfectly spherical, but so this is approximate, right? What does the equator represent? Well, that is actually a great circle going all the way around, right? So the equator all the way around is the circumference. So that 24,902, that's the circumference. All right, we know circumference is 2 pi r. So I'll put it in here. And then, equal to, and then, equal to 2 pi r. Divide by 2 pi on both sides. And make sure parentheses. Now, this is an important one. If you round too early, you're going to be thousands of miles off. Okay, so divide by 2 pi. You get a radius of about 3963.276. Now, even that, leave the rest in your calculator, 276,393. Leave that in your calculator. I'm going to write in up here. Look, I'll just write in 396.3. Okay. But I'm not actually using this number. I am going to use this number down here. All right, so just leave it in your calculator. Then you just square it, and then times 4 pi. So a very large number, 197,387,017.5. Go 3 there. About 197 million. If you rounded early, I actually got a number that this was going to be about 376.8 at the end. If you rounded early, you would have been over 300 miles off. Okay, so don't round too early. Again, let's see what this is in miles. So surface area. That's how much surface area is on Earth, okay, including water, right? All the covering. So, all right, let's finish up the last example. Surface area of a sphere with volume 808. Now, here's the two formulas. This is something I might give you. I'll give you a surface area, ask for volume, or give you volume, ask for surface area. Okay. So this one, I need surface area. So 4 pi, I just need the radius. Well, I got to use volume over here. What I know is that the volume is 808, so I'm going to plug that in for V. Okay, you've got to solve this equation for R. So there's a couple new things here. A couple ways to solve it. What do you want to do? Do you want to divide both sides by 4/3? Sure, that'll work. All right. Be careful though. You have to use parentheses. So that'll work. Now, sometimes though, I like doing this. It's a fraction in an equation. To get rid of it, let's multiply by the reciprocal. So divided by 4/3 will work, or multiply both sides by 3/4. Those will cancel out. Then I do 3/4 of 808, or I can do 3 times 808, and then divide it by 4. Okay, so I get 606. It's nice. I have a pi here. Then I'm going to divide both sides by pi. This will be an approximate. So I get about 192.896. Now, again, leave that in your calculator, but write this down. So what is R? Now, here's something. I heard that you've done this in Algebra 1, which is great. If not, if it was R squared, you'd do a square root. If it was R cubed, you do a cube root. If it was R to the 4th, you do a 4th root. All right. So where are these buttons on your calculator? What I need to do is let's go back to it here. I need to do a cube root of both sides. This side will just be R. Cube root. Now here's, on the TI calculators, it's math and then number 4. Okay. So I get about 5.778 rounded. All right, then I'll just put that in up here. I'll leave it there, and then you leave that number in your calculator, square it, and then multiply by 4 pi. Now, real quick, where is it on other calculators? Scientific calculator, it might look like this. You might see a button that says X radical. Okay, or actually, that X might be a little bit higher depending on the calculator. But it might look like this, X radical. So what you have to do is hit that button, and then you can choose what root you want to do. You can put a 5 in there, or 8, whatever. So that's the button you're going to use. It might be like, if you want to do a cube root, sometimes you have to hit a 3 first, then that button. But overall, it's that X radical button if you don't have an exact cube root button. Okay, so now I put this in. It's about 420 squared centimeters. Okay, I'm going to finish up there. Feel free to pause and look back. Thanks for watching.